Hey everyone, Mr. Allen. Just going to really quickly go over this concept of expected value. I find it's a concept that people struggle with, except if we're talking about it in terms of money, and then it seems to make a lot of sense. So we'll introduce it using money, and then we'll kind of come back to expanding it basically to just be any expected value. So this picture to the right is from the game show Deal or No Deal. If you don't know the game for some reason, maybe just take a quick minute and look it up. It's a very simple game. Probably of all the game shows on TV these days, it's the one that requires the least amount of skill and the least amount of intelligence. Really, it's a guessing game, and you can win money guessing. Yay. Expected value generally means what can I expect on average to happen. And in this case, what can I expect to make on average is really the question. So, given the situation that this gentleman is in, the bank has offered him $9,000 to quit the game. He has a case with one of these six values in it. And the question is really, if we forget about the psychology and the sociology and the financial situation that he's in, just mathematically speaking, is this $9,000 offer a good offer given that he has one of these, and we don't know which one, in his case? And so again, the math, pretty straightforward here. There is a 1 in 6 chance that he has 1 cent, a 1 in 6 chance that he has $5, 1 in 6 for each of them basically. And so the pure math of it is the expected value, so the expectation for his case is that 1 out of every 6 times it'll contain 1 penny, 1 out of every 6 times it'll contain $5, and so on up to this 50,000. And so when we multiply that through, we find that he gets that much money each time. We add them all up, and we find that the case essentially is worth $10,100. So his expected value, if he were to play this scenario out over and over and over again, on average, he would average winning $10,100. The bank's offered him $9,000, which kind of makes sense. It's a significant amount, but he has to understand that his case is worth more than that. Chances are good in this case that his next guess will be a low number and the bank offer will go up. So the bank offer actually is fairly close to the $10,000 that his case is actually worth. Started to get into the psychology there a little bit of why the bank would offer the 9,000, but the key here is just the understanding that if this situation were to come up for this gentleman over and over and over, first of all, he's a pretty lucky guy to sort of have that situation come up over and over and over where somebody's offering him $9,000 just to stop. But basically, the case itself is worth $10,100. Okay, so same question this time, deal or no deal. This young lady has 4 options now. She could be holding a $10, a $300, a $750,000, or a $1 million case, and the bank has offered her $275,000. So, same math. 1/4 of the time she can assume she's going to win this, 1/4 of the time she'll win this, and so on. Adding those values up then, so 1/4 of 10, 1/4 of 300, 1/4, and so on, we find that her case is essentially worth $437,577.50. So given that set of numbers, if she were to play it out, she would average that as her winning rate. Now, of course, you notice that this time the bank offer is substantially lower because, of course, it's a much bigger opportunity for her to lose money if she happens to hit one of these big numbers, where last time the gentleman was actually favored to probably get a better offer on his next turn. She's basically 50-50 to see one of these numbers come up on her next guess or one of these numbers. Again, getting into the psychology there a little bit more, but just the pure math is that given those 4 numbers, there is a 1 in 4 chance of each of them coming up, and so on average she can be assumed to make nearly $440,000 on the cases. Okay, so we'll take this one step further here. A second game here, dice or no dice. In this case, I offer you $5 to quit right now, or we'll play a game where you roll 2 dice and the payment is as follows. So if you roll a 2, you owe me $25. If you roll a 3 to 3, 4, 5, or 6, you owe $10. If you roll that magical 7, I pay you $200, and you see as we go across. So now, if we look at our frequency histogram here, so we need to sort of have an idea on the deal or no deal questions. Each case, each value had an equal opportunity to come up. I think you can assume that that's not the case here. Rolling a combination adding up to 2 or 25, 2 or 12, where you would actually have to pay the $25 is pretty rare. As we get to the middle here, we have more opportunity to get those values. So this is the histogram showing that to get a 2, there's only a one chance. To roll a 3, there are 2 ways to do it. To roll a 4, there are 3 ways, and so on and so forth. So we'll kind of make use of that in determining how our values will be used. In this case, there's a 1 out of 36 chance, basically again, one opportunity out of the 36 different possibilities where I roll a 2. There's a 1 out of 36 chance that I roll a 12. There's a 14 out of 36 chance that I roll something between a 3 and a 6. And again, that's just kind of adding up the 2 possibilities here, the 3 possibilities here, the 4 here, and the 5 here. And there's a 6 out of 36 chance, 6 ways that I can roll a 7. And so, not sure why that's so far down the screen, but pull it up here. So the expected value in playing this game now is what we're interested in. There's a 1 out of 36 chance that I lose $25 by rolling a 2, 1 out of 36 chance that I lose $25 by rolling the 12. So there's a 2 out of 36 chance that I lose $25. There's a 28 out of 36 chance that I lose $10. And there's a 6 out of 36 chance that I win $200. And if we actually work that out, what you see is, or what you find is, that the expected value overall each time you play this game is that you're likely to win on average $24.17. So this is a situation where even though you can look at this and clearly see that the majority of the time you lose, in fact you lose 30 out of 36 times, so 5 out of 6 times you lose, 1 out of 6 times you win, that in the long run this is a winning game. So this is one of those situations where if somebody asked you to play one time, you might say, I don't think so. But if they offered you to play for as long as you wanted to, you recognize that in the long run you're likely to win, and you might want to consider it.